everyone. So the paper that I'm going to present is by Andrea and Miklos. So it's about third-party generated information from social media and how we can enhance the substantive analytical procedure.
Hold on a second, Yumi. This paper has been rejected on a journal, and we are going to resubmit. So this is the perfect moment for you guys to send me and Andrea insightful comments about it. Go ahead, Yumi.
Okay.
Professor, are you recording this?
Yes, it's recording.
So this examines the usefulness of third-party generated social media information for firms, brands, and products in enhancing regression-based substantive analytical procedures. Later, from here, we're gonna call it SAP for the revenue account. Analytical procedures are defined as reasonableness tests, where auditors compare their expectations of account balance with those recorded by management. Although SAPs may offer a cost-effective alternative compared to the test of details, PCOAB inspection findings often identify several deficiencies in auditors' applications of SAPs. So this study explores the prediction and error detection performance of SAPs and also include Twitter proxies for customer interest and customer satisfaction. And also use the monthly revenue data for 20 business-to-consumer industry and aggregated third-party generated Twitter comments. And the results of this paper suggest that the SAP that include TCI, which is Twitter Consumer Interest, is more useful than SAP that includes TCS, which is the Twitter Consumer Sentiment. When compared to the benchmark, SAP that includes firm-specific information and traditional exogenous indicators such as GDP. So, purpose of analytical procedure is to evaluate financial statement information by analyzing possible relationship between financial and non-financial information. So, auditors perform analytical procedure in 3 steps. First, they develop an expectation for account balance or ratio. And second, they compare the difference between the expected account balance and actual account balance recorded by management. And third, they investigate difference exceed the materiality threshold. So if difference do not exceed the materiality threshold, auditor assess whether additional audit procedures are needed. So what is the benefits of using the third-party generated information? Using third-party generated information as a complement to analytical procedures that include traditional information may help auditors develop better account expectations and detect accounting errors. There are 3 principles of audit evidence. First, sufficiency, second, relevancy, and third, reliability. And third-party generated information is voluminous in nature and relevant because it is timely and sued as a proxy for used, not sued, I'm sorry. It is because timely and used as a proxy for customer interest to buy and satisfaction. And third, it can be best described as aggregated opinion of non-corporate social media users about firms, brands, or products. And also, it is easily accessible to audit at the time of audit. So there are 2 research questions in this paper. First research question is for the revenue account. Do the analytical models that contain traditional and Twitter-based information produce more accurate prediction than the analytical model that incorporates only traditional information? And second research question is for revenue account. Are the analytical models that contain traditional and Twitter-based information better able to detect errors than the analytical model that incorporates only traditional information? So they used the 3 measures from Twitter's. First, recent, past, and future consumer interest, and second, positive, and third, negative consumer sentiment. So if you see the right The first is the example of Twitter consumer interest. So it's the volume of third-party Twitter comments. And if you see the down below, that's the examples of Twitter consumer satisfactions, which is the ratio of total number of third-party Twitter comments that indicate both positive and negative sentiment. And this is a correlation graph for TCI, suggests that is positive with revenue, especially during Q4. And for TCS, observes negative correlations, which suggests that positive sentiment does not necessarily translate to increase in sales, and vice versa. So, how they select a sample. Financial statement information related to quarterly revenue and accounts receivable is collected from Compustat Fundamentals Quarterly Database. And next, GDP information is obtained from Bureau of Economic Analysis website. And this information is collected from period 2012 to 2017 for the 194 publicly listed companies for which the data provider collects Twitter information. So this is like total number of the samples that after eliminate some of the data which is not doesn't have the information. So total from is 76, and the quarter observation is 1,824, and monthly observation, if you do, multiply 4, that's about 5,000 observations. And the descriptive statistics of financial information of the samples from 2012 to 2017, and revenue, account receivable, and advertising expense. And this is also just descriptive statistics of Twitter information on the final samples about the volume of Twitter comments, which is Twitter consumer interest, and the sentiment, positive sentiments and negative sentiments of Twitter comments. And this is the model that they used to check the hypothesis. So research questions. So they used linear regression. So, which is a similarly effective or more effective than sophisticated models, less demanding. And these are so this is the models that they use for different models, and models there's a explanation of the each variables. So if you see if you see GDP, that's just exogenous traditional data, and TCI is interest, TCS is sentiment, and ADE is advertising expense. And to compare the models, they use the adjusted R square of each four models, and it's calculated aggregated at the industry level to assess of it. And out of sample prediction performance evaluate using MAPE, and this is the formula for that, which is the absolute difference between actual and predicted divided by actual value. And small MAPE is better because it means a smaller forecast error. And also they use false positive and false negative to measure the error detection ability of each model. And smaller error rates are preferable. And false positive are tested by using quarterly financial information. And false negatives are seeded into the revenue accounts, which is 2% of the revenues. And alpha is the audit risk levels. So generally, a smaller alpha will lead to a wider interval and fewer false positive, but larger false negative resulting in lower detection rates, while a larger alpha will lead to a narrow interval and larger false positive, but fewer false negative. This is the results. So if you look at it, so MAPE is the MAPE for model 1, and MAP2 is MAPE for model 2, which has TCI. So if you look at the results, you can see that the MAP2 is smaller than MAP1 in most of the
Jimmy, you can say MAPE. That we usually call it MAPE.
Oh, sorry. Yeah, Mate 2 is off. That's much easier. Thank you. Most look at the most of the company has smaller Mate 2 than Mate 1, and also adjusted R square is greater. That you can see that it's greater in Model 2 than Model 1, which is the model that's better. And on the right side of it, you can also see that Model 3 is better than Model 1 because it shows a smaller map in the overall companies. And also R square does better for Model 3. Model 2 and yes, so this also you can see that Model 2 has a smaller map and R square adjusted R square is greater than Model 1. And if you look at the Model 4, which is including advertisement expense, it's significantly better than Model 2 and 1. So, so the overall TCI leads to superior prediction performance when compared to the benchmark model and the model with CTS. And the model with TCI produced reasonably improved account prediction when compared to the benchmark model. However, when using advertising expense as a traditional proxy for firm generate consumer awareness of brands and products, the contribution TCI is limited. As a result, so you can see that if you look at the left side of it, the difference between these two, and if you look at the difference between these two, the difference between Model 1 and 4 is greater than 1 and 2. So this is what it's talking about. And as a result, a model with advertising expense can lead to improved prediction performance when there are no errors in revenue account. And another results about error detection performance for the research question 2. Auditors are primarily concerned with the high litigation cost associated with not identifying material misstatements, which is first negative. Also consider the cost of performing additional, but auditor also consider the cost of performing additional audit work for unusual times that do not translate to material misstatements, as this has an impact on budgets, which is related to false positive. Hence, an effective model for error detection should produce relatively low false positive versus negative errors, of course. So if you look at the results, you can see that in the false positive, the model with TCIs do more better in major company, and false negative, there's not much difference, but it's like that. There's not much difference false negative. And if you compare the ratio of it, so 1 to 1 is considering that false positive and false negative cost are same. And 1 to 2 means that false positive is half cost than false negative. So if when there is a same cost, I mean, in both cases, you can see that TCI is a little better than benchmark. And also comparing model 1 and 3, also for first positive, TCS is better than benchmark, and this also TCS is better than benchmark. Also the ratio part, I think TCI is like TCS is inferior to the benchmark model. So in summary, TCI can be valuable in detecting of errors in the revenue account for many of the industry in the sample. However, to discern the incremental value of TCI for error detection now compared to model 1 and 4 with advertised expense. If you compare this, regarding false positive, advertise is superior than the benchmark, and false negative benchmark is superior than advertisement. So in the ratio test, it's like because the first negative is better, advertising do better in first positive, Advertise better when the price is same, and when the price is half the first negative, benchmarks do better. So TCI can contribute to the detection of accounting errors even when it is compared to the model that includes advertising expense as a proxy from generate consumer awareness of brands and products. Consequently, auditors could benefit from implementing an analytical model that incorporates information that is generated by consumers on social media to predict revenue, account balance, and detect accounting errors within it. So the contribution of this paper added value in auditing literature in analytical procedures by investigating the incremental contribution of information that is generated by third parties and social media platforms. The limitation is first, monthly observations are estimated from quarterly observation, while this is interpolations methods have been applied in prior research. It is possible that the estimated monthly amounts do not actually reflect the actual recorded account balance. And second, the study focused on 20 business to customer industry only. And also third, only one social media platform exam. Yeah, and that's it.
So, what do you guys think of this?
I was thinking it's just like minor thing, but I was thinking there's a showing the negative relationship between TCS and I'm going back right here. There's a negative relationship. Maybe if you look at this example right here, it sounds like it's negative sentiment, but it actually doesn't necessarily mean it's negative because this person say that iPhone 6 start acting badly, so this person is getting another iPhones, which is contributing to revenue. So it's hard to decide whether this is negative or positive sentiments. So maybe the relation showing this negative, maybe that's a part of the reason.
Okay. Ching, what do you have your hands up? Let me see what you think.
Yeah, I think maybe the revenue is not that accurate to predict. I mean, to use the sentiment analysis to predict revenue is not that accurate because, for example, like iPhone, they have so many products, and each product, the price is quite different, and the customer's reaction to different product is quite different. Maybe they are not very satisfied with iPhone 8, but they like the iPhone X very much. So if they express a lot of unsatisfied on the Twitter, you may predict this is a negative reaction. But they like the iPhone X, and the price of iPhone X is much higher than the iPhone 8. So I think that may be a little biased.
Yeah, I think this is a good comment. In the work from Kelly with cleanliness of city of New York, they reduced it from like 7 million comments to a few thousand. And the real question was the ability to classify utterances in a proper way. Because sometimes they're double negative, sometimes they really don't have anything to do with street cleanliness, and maybe she missed several of the other ones. So yes, the extraction of the comments and the method have a big influence here. Andrea.
All right, so here we go. Yeah, so I thought it was very interesting, and it's a way to quantify something that it's supposed to happen, I think, in analytical procedures, because auditors are expected to look at things other than just the numbers in the financial statements to create those expectations. So I think it's a good way to quantify it. Now, I was thinking perhaps if there was a way to capture the comments as compared to the major competitors' comments to have more predictive value. I don't know if that's possible because I mean, we might see a lot of increase in the positive comments for a company, but if there's a higher increase in the positive comments in the competitor or substitute kind of products, it might not really influence the sales as much. I don't know, just it just came to my mind, and I was reading, so I thought just to say.
Yeah, meaning I think this comment, like Ching's before and your comment, has a lot to do with detecting if the nuances of a comment, correct?
Yeah, exactly.
Yeah, and basically these are the weaknesses of our semantic analytics that don't understand very well the issues of semantic. The other thing is that the language used in tweets or in Facebook comments, etc., is kind of common American abbreviated and abused language. So you can't really trust formalization. In a study we did at Bell Labs, in the MIM study, we basically ran comments to spellers and to grammar correctors to be able to deal with it better.